Hello friends. In today's class, we'll talk about the second last phase of the compiler, which improves the code by various technique called code optimization. The next phase here in this case is code optimization, and this code optimization phase is a bit tricky. But there are two categories of the code optimization technique. One is machine dependent code optimization, and another one is machine independent code optimization. So during this intermediate representation, few code optimization technique is applied. What is the overall goal over here is to improve the intermediate code. Okay, that is an attempt to improve the intermediate code, and that is a faster running machine code will result. Okay, so we want to optimize, and optimization is one of the criteria almost in every field that we want to optimize our result. Some greedy approach can be, greedy approach is one of the approach algorithm design technique where we do optimize optimization problem, optimization criteria, maximize and minimize. Minimization may happen. So one simple example I can give you of this code optimization, though I have not kept the same problem for each and every phase, is here you can see that A is equal to B multiplied by C, and if I generate a intermediate code for this, then I will generate something like 3 address code. Let's say temp1 is equal to B multiplied by C, and then I will say temp2 is equal to temp1 plus G, and finally A is equal to temp2. Then I will say here for this code that again let's say temp3 is equal to B multiplied by C, and then I can say okay, 3 address code is there, so finally I can say okay, D is equal to, directly you may have, I can write this two thing in a single sentence, D is equal to temp3 multiplied by E. Here also I can combine this two step as is in this way. A is equal to temp1, and directly I can say G rather than two step. So this is the idea, and but you just observe here that temp1 is consist of the value B multiplication C, B multiplied by C, and this part also is temp3 is also consisting of B multiplied by C. Now optimization is one of the criteria, and what I can do here, I can just remove this common sub expression, right? So what I can do over here, rather than computing 2 times B multiplied by C, I will just write here the code in this way that temp1 is equal to B multiplied by C. Then I will say A is equal to temp1 plus G, fair enough. And then I'll say D is equal to temp1 multiplied by E. Okay, so I can perform the same task in this way, and this code where when we finally going to translate into machine language, this is going to take there will be a multiplication statement for this one, and there will be another multiplication statement for this one. So that will consume more number of cycles. Okay, it will consume more number of cycles. So to avoid this thing, now if you compare this code and this code, definitely this will take less number of cycle, and the code will run. Ultimately code will result in code will be faster in running, less number of cycles. So that is the idea of code optimization, and code optimization is applied at 2 levels. One is at machine level, and machine dependent and machine independent.